welcome to this genes video. In this one we're looking at the microscope, and the reason we're starting with this because we're talking about genes. We talk about some very small things and we need microscopes to be able to see them. So let's make a start, shall we? Okay, this is a beautiful picture. This is of a virus. Now all living things are made up of cells. Now they are so small that you really can't see them with the naked eye, so we need to use what we call a microscope. Now let's do a little history lesson here into the microscope. Now this picture here is one of the first microscopes ever invented, and this was made by a Dutchman called Anton van Leeuwenhoek in 1674. Very basic design, and it was utilised by many scientists, including some guy called Robert Hooke. Now Robert Hooke looked at cork tissue under a microscope. Now here we can see cork cells. This is his actual drawing here of cork cells under a microscope. Now he used the term cells to describe what he saw because it reminded him of the small rooms that monks lived in. I never knew that. That's why they're called cells. Now we then developed it quite quickly. This is an Italian compound tripod microscope in about late 1600s. They evolved then to this Italian compound microscope, 1726. You can see here that we've got lenses we can actually slip onto it. So we start changing here the lenses of the microscope. And this one here, about 1831, you can start seeing the basics of the modern microscope. And moving on to some other scopes here, here's a Spencer compound monocular microscope, and this is 1904. And in this one you can actually see, let's go back a second, sorry about that. You can see here that we've got the basics of everything we see in these modern scopes here. This is a modern monocular microscope. It's got one eyepiece. This is a modern binocular one. Now this is much more comfortable. I prefer using these. They're much more comfortable to view through. That's a modern binocular microscope. Now if we want to see things really small, we've got to move away from using light, instead to using what we call electrons. This is an amazing picture of a tiny mite taken using one of these electron microscopes. So electron microscope uses beams of electrons to view objects rather than light. So it doesn't use light at all. It uses beams of electrons. Now electron microscope can magnify objects over 500,000 times larger. That is amazing. And here we've got an EM electron microscope picture here of bacterial cells. So magnification of these is actually incredible. Okay, so let's look at our light microscope. If you can get a drawing to label, that'd be wonderful. Let's see what we've got. Well, here we've got an eyepiece lens at the top. This is called the tube body or body tube. Here we've got the lenses. So often on a microscope like this you might have three lenses here. They're called the objective lenses. So you might have a high and low and a medium power objective lens. This is the stage. So the slide you're going to make sits on top of the stage. Now the mirror, some microscopes have built-in light sources, some have mirrors, and the mirror is used to bounce light. Comes here, bounces there, and comes through there so you can see it clearly. This is the handle here, carry it with, and this is the focusing knob that you move so you can focus it really clearly. So that's labelling. Let's look at using the microscope. Now always use the handle to carry the microscope. The handle is this section here, so always carry it using this bit, perhaps even supporting it underneath the other hand, but never carry it by the tube here. And you're going to use light from a lamp or a window and angle the mirror so light shines up through the stage. So if you've got a mirror, you angle this mirror here so light comes in, hits the mirror, and then comes up then through the stage. You can see it clearly. But you might have a built-in light source, which is much easier. Select a slide with the object you want to look at and clip it onto this bit here. So there's some clips here on the stage. So clip it on there and the clips hold it in place firmly. Always begin with choosing the lowest powered lens. Lowest powered lens is the smallest one. So this part here rotates. As it rotates you can bring into view different lenses. So use the smallest one first of all. Now when you start to try to focus it, always don't look through the eye tube, look from the side here. So get your eye level down here and then lower the objective lens. So lower this until it's just so this bit here is just above the slide. Okay, so do that from the side. Now look through the eyepiece and then focus these. Use a focusing knob. Here's a focusing knob here. Use it to move the eyepiece lens, sorry, the objective lens, upwards until a clear image is formed. So all this is going to move upwards till a clear image is formed. Now if you want a greater magnification, simply rotate the turret here to get a bigger lens. So if you need greater magnification, switch to a higher powered objective lens by turning this part here. And if you do that, you'll need to refocus the microscope to get a clear image. The bigger the lens, the higher the magnification, the harder it is to really get a clear image. You have to be really careful to focus it. Okay? Right, now, if you're going to use a microscope, you want to make a slide. And one of the easiest ones to use is an onion cell. So, if you like onions, if they make your eyes water, I apologise about that. But let's have a go at making an onion cell slide. So, first thing to do is cut open an onion. Secondly, use forceps. You can peel a thin layer from inside. This is a really thin layer. If you're very careful, you get this really thin, transparent layer you can peel from the inside. Having got the layer, spread it out in one smooth patch on the slide. Now, they're difficult to see without staining, so use what's called iodine. Use a drop of iodine solution and add it to the layer, and you'll hopefully see then onion cells. Then 5. Carefully place what we call a cover slip over the layer. Really careful to do that so you don't trap any air bubbles on your slide. Having made your wonderful, beautiful slide of onion cells, you want to draw them. So, a few pointers. First of all, use a sharp pencil. Now, pencils come in various categories. If you look on it, it will say somewhere HB. That's the best pencil to have. And don't use pen, and don't use colours. So here's my rather tatty drawing here of a slide. You can see it's this one here. I managed, using my mouse, I've drawn this cell here, and there you can see it. So outline the features as accurately as you can. Don't draw what you think is there, but what you can actually see. And this is a drawing, so we're not going to be shading it. Okay, we're not sketching this, so use as little shading as possible. When you've drawn it, label your drawing with the name of the sample, onion cell, and the magnification used, times 100. Oh, how do you work out magnification? Well, to work out magnification, you look at this one here. On the top here, it'll tell you what the eyepiece lens magnification is. Down here, it'll tell you what the magnification of the objective lens is. And to work out the total magnification, simply multiply the two together. So if eyepiece lens is times 10, objective lens is times 20, 10 times 20 is times 200, and that is your total magnification. You multiply the cell view by 200 times. Okay, a couple of keywords. Light microscope, device that uses visible light and a series of lenses to produce an enlarged image of an object. And the cell is the basic unit of life. Unicellular organisms only have one cell, whereas multicellular organisms have many cells. So copy the keywords onto your vocab sheet. Well, that's the end of this Key Stage 3 science video. Thanks ever so much for watching. I really do hope you like what you see, and if you do like what you see, why not visit my website at www.keystage3sciencecourses.com. There you'll find over 120 science videos you can subscribe to. So once again, thanks for watching, and bye bye for now.